5 different types of reactions. Josh, can you mute yourself, please? Thanks. We've dealt with synthesis, which looked like this, 2 individual things that form a compound. We dealt with a decomposition, which is this breaking apart. We dealt with a double replacement, which is 2 things switching partners, which we're going to go on a little more in depth. We talked about single replacement, where one thing replaces something else in a compound. And we talked about combustion, which is something a hydrocarbon reacts with oxygen and it breaks apart. Today, what we're going to do is we're going to talk about double replacements a little bit more closely. And I'm going to show you a PowerPoint here. I'm going to share my screen with you. Let's have Trey. Can you unmute yourself, because you're going to be my verbal responder here. So when I ask questions, everyone I can hear through his laptop as soon as he unmutes himself.
Yeah, why don't you let me do that?
Or Ian, sorry. Ian.
Yeah, I'll do it.
Okay. So Ian will be the person to kind of respond just to give me a feel, because I'm not going to be able to look at you guys directly because I'm going to have this on your screen. I am going to start sharing right now. And
whoa.
Okay. So double replacements are whenever you have 2 compounds together. But the reality when you have 2 compounds together is that not both of them will form a solid. So what we're going to talk about right now, we're going to talk about precipitation reactions or net ionic equations. It sounds kind of tricky, but it really is not so bad. I'm going to walk you through a sample here. Can all of you guys see the PowerPoint that's on my screen? Ian, can you respond here for me?
Yes, sir.
You guys can all see it?
Yes, sir.
Okay.
Yeah.
So I want to point out a couple of things here. So in the past, when we see written MgCl2, I hope you can also see my pointer here circling around that. Ian, is that correct?
Yes, sir.
Okay, wonderful. Whenever you see the letters AQ next to something, AQ means dissolved in water. What that means is that it's not actually a solid like MgCl2. It's actually broken apart into its individual ions. So one of the things that we've not done so far with the double replacements is we never worried about what the state of matter was. But from here on out, when you look at a double replacement, we're going to focus on whether or not parts of it say AQ and parts of it say solid, liquid, or gas. The AQs we're actually going to split up in our mind. So let me show you how this works. If you look at MgCl2, MgCl2 is actually 1 Mg2 plus ion and 2 Cl minus ions. And that, you can see that by, there's a 1 next to the Mg, and that's an Mg2 plus, and there's a 2 next to the Cl. So that means there's 2 of these Cl minuses. So if we were to write this, the way it actually is, MgCl2 when it's in water actually splits apart because it's aqueous and it means it dissolves in water. So it's really 1 Mg2 plus and 2 Cl minuses. Similarly, if we looked at NaOH, if we broke that apart, and let's say there was, and by the way, the only time we're breaking this apart is if it says AQ next to it, aqueous, then this would actually be 1 Na plus and 1 OH minus. Now, whoa, that was loud. Now, if I were to combine these two, MgCl2 aqueous and NaOH aqueous, they together would form a precipitate or a solid, which is the other side of an equation. So let's take a look at this here. Now, what we've been doing so far is we've been writing complete molecular equations. In other words, we've been writing all the molecules. But we can also write them in ionic form and net ionic form. That sounds confusing. Let me show you what I mean here. So this is the equation we just were talking about. See how it says 2NaOH aqueous plus MgCl2 aqueous yields MgOH2 solid NaCl aqueous. So these 3 things, NaOH, MgCl2, and NaCl, they're all aqueous. What that means is that they really aren't a compound. Those are actually broken apart and they're actually ions. So if we were to write the net or the complete ionic equation, in other words, instead of writing, and by the way, the only reason they write NaOH aqueous is because they didn't want to write Na plus and OH minus, right? This 2 in front, this is a balanced equation. So that 2 actually impacts how many of each one we have. So if we were to break this apart, since it's aqueous, see how this reads as two NAs because there's a two NA, and it's an Na plus because it breaks apart into its ion. And see, it says two OH right here, and so we have two OH. Similarly, if we have MgCl2, there is no coefficient in front, so wouldn't that mean I have one Mg, but it's an ion, so it's right, it's Mg2 plus, and we have two Cl minuses, so right, it's two Cl minus. Now, over here we have MgOH in parentheses 2. That's a solid, which means that it does not break apart. And you see how we have to write that as one single compound. Then we go back to NaCl, which is aqueous, and that means we have two Na pluses and two Cl minuses. Any questions here so far?
Any questions?
Thomas.
No.
Okay, so watch. This right here is every ion that's written out here. And by that, I mean anything that says aqueous, we're going to have to write it out as its individual ions. Anything that's a solid, we keep it as itself. This is the complete ionic equation. Remind yourselves that the 2 in front of these actually applies because this is a balanced equation. Now, the net ionic equation are only the ions that form the solid. So if you see this, it says we're going to drop out the ions that float around from reactants to product side. So take a look here. Would you all agree that if I were doing this on the board, I'd have Caroline or someone underline MgOH in parentheses 2? Would you agree with me that's the only solid thing that's in the entire equation? Ian, is that yes? So
Yes, sir.
what we want to do is we want to find only the ions that are involved in forming that. The other ions aren't involved in forming the solid, and they're just going to keep on floating around in the solution, so we're not going to include them. So if you take a look, the things that are in yellow here, the Na and the Cl, they clearly aren't part of MgOH in parentheses 2. The only two things that are part of MgOH in parentheses 2 are the OH minus and the Mg2 plus. So the ions that are not involved in the actual equation, we call those spectator ions, just because they spectate. They don't actually contribute to our formula for our solid, which is MgOH in parentheses 2. So when we write the net ionic equation, let me sidebar here. You know, in finance, you have your gross, the total amount that you get, and then you have the net that you gained, and the net that you gained is the total that you got minus all the expenses that you had. So we only care about the net. Well, here
What happened? I think Lindsay broke it. Can you hear me, Mr. Dimitrovitz?
Do I never rely on technology kids?
Hold on,
Did you fix it?
it broke.
okay.
Oh.
Can you guys hear me?
Yeah, I fixed.
Okay, you're okay. Stephanie, would you mind spitting out your gum for me, please? All right, so I'm going to go back to what we were doing here. Any questions so far on what I've been sharing with you?
No, sir.
Okay. Maybe I'll ask Libby to decide what sort of punishment we give to Stephanie for gum chewing, since she's a veteran in the gum chewing world.
It's
Oh no, it's Caroline. My bad. You're right. I'm going to go back to what I was doing here because, again, we don't have a ton of time in class today. So I'm going to go back to our PowerPoint. And what I want you to see is this. Whenever you have a long equation of all these ions written out, we're only going to be concerned with the ones that form the net ionic equation, which are the ones that form the solid. So in this case, it would be Mg2 plus and 2OH minus. So now let's take a look at this here on our own. And I want you to kind of cover, if you would, in your mind, the stuff down below, because I want you to see if you can set this up yourself. So this is the overall equation, and this is, if you look at it, this is like what our double replacements would look like. So you have HCl and NaOH. It forms NaCl and H2O. We just did a double replacement. H hooked up with the OH, and the Na hooked up with the Cl. Now, notice something here. Aqueous means that these things are actually as ions. They're dissolved in water. So HCl is aqueous, NaOH is aqueous, NaCl is aqueous. H2O is the only liquid. Now, if we were to write all of the ions out, each of these things that are aqueous, we break them apart into their ions. So HCl would be H plus and Cl minus. NaOH would be Na plus and OH minus. NaCl would be Na plus and Cl minus. And H2O, see how that's a liquid still? We write it as a liquid. Now, if you take a look at H2O, what are the only two things that make up H2O? Aren't they H plus and OH minus? Everything else, the Na and the Cl, they aren't involved in forming our H2O. Now, again, let me remind you why we care about the H2O. Isn't the H2O the only thing here that's not aqueous? See how it says L next to it? Now, if something says L, S, or G, liquid, solid, or gas, any of those three things, then it's going to be what we're forming in our actual reaction, our net ionic equation. So notice here, out of all these right here, H2O is what we're forming on this side. Then we need to grab the ions that were put together to form the H2O. And the two ions we put together are H plus and OH minus. That gives us our net ionic equation. Any questions on that? Ian, you're supposed to give me a verbal response for everyone.
Yes.
Okay. Any questions from anyone?
No.
Okay. So, blah, blah, blah. Let's take a look at this one here. And again, if I could, I would cover this bottom thing up altogether. But I want you to take a look at this equation right here. Don't worry about the wording. Up above, all I want you to do is look at the actual equation. See what it says HCl, Na2S, NaCl, and H2S? Now, the only thing that is not aqueous, isn't it the H2S? Everything else form ions. So if I were to ask you to write simply the net ionic equation, realize that all these right here, even though they're written together, HCl aqueous really means H plus and Cl minus. Na2S aqueous really means two Na pluses and one S2 minus. And NaCl aqueous really means Na plus and Cl minus. The only thing that stays together as a whole is H2S. So if we're trying to write our net ionic equation, we only want the ions that form H2S. So I'm going to put H2S as my end product because everything else is aqueous. And then I want to find the ions from in here that form the H2S. And if I look up here, the Na2S, the S2 minus is aqueous, and that form. And then if we pulled the H from here, don't we need two of these H pluses to make up H2S? And this would be our net ionic equation. Now, I skipped a step in this step right here because you're probably going to want to skip that step too. Instead of writing all of the ions out, which you could have written H plus, Cl minus, 2Na plus, S2 minus, Na plus, Cl minus, and H2S. That would have been our complete ionic equation. We decided to just jump to what forms the actual ion or actual compound. Any questions? Yes, no, maybe?
Yes. Wait. No.
No? Okay, I need someone to go up on the board really quickly now again. So I don't know if you know the challenge.
Yeah, I'll turn my camera for you.
Okay.
Here,
I'm going to
Caroline.
stop presenting right now.
Wait, hold on. Here, hold this for a second.
No, that's for the other classes.
Put it to where you can see it.
Go towards the left side of the board if you can.
Sorry.
I'm curious as to what got knocked over, but I kind of don't want to know.
Yeah, it's best if you don't know.
Can you tilt the screen maybe down a little bit here and then erase what's on the board there to the left-hand side? Okay. So let me show you a complete, a regular molecular. You're chewing gum too, Carolyn. Look at you. Even after I told Stephanie to spit out her gum. Wow, that's a bold move. Okay, let's write this equation down. We're gonna do a molecular equation first. So let's write NaCl aqueous plus AgNO3 aqueous goes to AgCl solid plus NaNO3. And I realize that I should switch over to what you guys are doing, what you're doing on the board. Okay, so those of you who are watching this later, this is the equation. So what I want everyone in the classroom right now to do is I want you to write all of the ions. I want you to write the complete ionic equation underneath it. So all the ions, the only thing that's not going to be written as an ion is AgCl. Caroline's going to do this on her own as best she can, but I want all of you right now, I can see all you guys working right now. I want you all to write the ions on this. Yeah. Caroline, can you start writing the ions on the board, please?
Wait, what are we doing? Wait.
So
I wasn't here for the first part of it, so of like your lesson. So
okay, so let's work together. So let's go to NaCl at the very beginning here. That AQ actually means that that's dissolved into its individual ions. So what are the two ions that are involved? Isn't it Na plus and Cl minus in NaCl?
yeah.
So I want you to write Na plus and then right next to it, Cl minus. But separate them apart so we can see that they're two separate ions, and write AQ next on the bottom of each one. AQ means that they're just dissolved in water. So just write Na plus and then AQ down below. And then Cl minus right next to it. And write AQ. Okay. Now, oh, thank you for putting that on there. We have a very short period. We have 10 minutes left. All right. So anytime you see an AQ up above, that means that that compound is actually written as ions. So see how we have AgNO3? If we broke that apart into ions, wouldn't that be Ag plus and NO3 minus?
Can I put AQ?
Yes, please. I mean, when you were doing these on your own later, you can probably skip this step. Put an arrow. And can you put it between the Na and the Cl? Can you put a plus as well? Between the Na and the Na, yep. And can you put it between the Ag and the NO3? Can you put another plus? These are all the ions. So right now what we have are four different ions, and they're
Sorry. Okay.
okay. On the other side, the AgCl, see how that's a solid? So we have to write that as AgCl. So let's write that as AgCl.
It's Ag plus.
No. This because it's a solid, we don't break it apart. We just write it exactly like it is up above. So you write AgCl solid. Lindsay, did you mute me? How can you hear me? It says I've been muted by you. I don't know why that is, but okay. Can you scoot over to the side a little bit here so I can see? Okay, so if AgCl is a solid, and then NaNO3 should have written, there should be an AQ next to it as well up on the very top.
Okay.
And again, what does AQ mean? It means that it's something that's dissolved. So we're going to write this as Na plus and NO3 minus. Okay.
3 minus AQ.
Yep. Okay, take a different color pen really quickly. And this is what I want all you guys to do. So I want you to underline the AgCl solid on the right-hand side. On the right-hand side, right there. Underline on the bottom one, the net ionic. Yep. No, that's fine. That's fine. Okay. We are trying to form that from the ions that are on the left-hand side. So can you underline the two ions on the left-hand side that we're going to put together to try and make AgCl? Everyone can do this along with it. Wouldn't that be Ag plus? Do it on the second one, the second equation. It's fine on the top one, but we've already broken apart. Ag plus and underline Cl minus. So do you agree with me that those are the two things that are going to put together to form our solid? Does everyone see this? Can I get a thumbs up if you all see this? Okay. So then what we're going to do is we're just literally going to write a net ionic equation, and the net ionic equation is simply only the ions that are forming AgCl. Now, I like to do it in order. So see how the positive ion always goes first in our compounds? I like you to write underneath there. Can you write Ag plus? Aqueous. Plus Cl minus. Aqueous. Goes to AgCl solid. Now, even though the aqueous is super big, do you see how all we have right now are the things, the net ionic equation? Net ionic means only the ions that are forming the solid. Now, when I say forming the solid, that could also be a liquid, that could also be a gas, but Ag plus and Cl minus form AgCl. Can you put your finger on Na plus up above? Right there, Na plus. Does that Na plus have anything to do with forming AgCl?
No.
No. So we call that a spectator ion. Similarly, put your finger on NO3 minus. NO3 minus, that is not involved in forming AgCl. So that's also a spectator ion. So those are just floating around. We don't include them in our net ionic equation. Are you guys all with me right now? Let's try one more. Let's erase everything. And I want all you guys, I'm going to give you like 2 minutes here, or actually about a minute. And I want you to write the net ionic equation for this reaction I'm going to give you right now. Let's go. Let's go Ca NO3 in parentheses 2. Just the parentheses only around the NO3. Okay. Plus, you can write aqueous next to that, please. Okay. Plus Na2SO4. Make sure that's a subscript. The 2 looks like it's a.
Oh, yeah, sorry.
Sorry. And can you write aqueous next to it? And an arrow.
SO4
And on the other side, can you write CaSO4 and write L for liquid plus NaNO3 and write that aqueous. Now, is that a balanced equation right now?
No.
In order to balance it, what do we have to do?
We have to bring the 2 up, right?
Well, that's to reverse, but we have to make sure we have the same number of NO3s on this side as we do on the other side. So don't we have 2 NO3s on this side? Don't we have only 1 NO3 on the other side?
So you put 2.
So we're going to put a 2 in front of the NaNO3 on the right-hand side.
Okay.
Right there. Yep. Okay. And I think that balances us out. Can anyone verify here? I think we're good. So here's what I want all of you to do.
Hannah has a question. She wants to know why we don't have the SO4 in parentheses.
Oh, because there's only one SO4. You just froze. So I don't know if I just lost you or. Okay. So I don't know if you guys can all hear me, but the only time you put parentheses around something, a polyatomic ion, is if you have more than one of them. So put your finger on the NO3 on the left-hand side. Right there. Okay. Do you see how we have 2 NO3s? So if we have 2 NO3s, we have to put a parentheses so everyone knows that the entire NO3, we have 2 of them. Put your finger on the SO4 on the left-hand side. See how we only have 1 of those SO4s? So we could have put a parentheses and write parentheses 1, but because we only have 1 of them, we just don't do that. Does that kind of make sense?
Mm-hmm.
Any other follow-up questions on that? Okay, so here's what I want you to do. All of you right now, and Caroline, you're going to work on this as best you can. I'm going to give you guys 1 minute, and I want you to write the net ionic equation for this. It might help to write all the ions first, but I want you to write the overall net ionic equation. Go. All you guys should be working on this.
What do we do for the, since this is like NO3 minus, what do you do with the 2 right there?
You put a 2 in front of the NO3.
Okay.
Wait, what do we do with the aqueous and the liquid?
And I'll tell you what, just to make this not confusing, we know that everything's going to be aqueous except for the solids. So, Caroline, if you want to just exclude the aqueous for right now, it'll make it easier in your equation. But can everyone understand that what she's doing right now is not perfectly correct, because you should have aqueous next to it. By the way, Ca is a 2+.
Okay.
So write Ca2+, and then plus Make a plus in between.
Yes. 2 and 3 minus, right?
Yes, ma'am.
Mm.
Does it matter what order it's in?
Not at all.
Right.
Not at all. The general form that we have is we always want to have the positive ion written before the negative ion in each case. That's SO4 2 minus, hon.
Oh,
Really important that we know what our polyatomic ions are, or else it's going to really hurt us.
I was thinking about that.
Yep.
Mm.
Mr. Ambiel, what's written to the right-hand side of where you're doing the schedule?
This time, well, it's
Well,
map-
I'm just thinking here that for the next classes, I may need a little more space on the board, but let's leave it like that for right now.
Okay.
I didn't know if there was something that was really important to the right-hand side.
No, it's just show us some time. Resolve
Okay.
it.
Okay, now CaSO4 isn't that a liquid?
Yeah, it's a liquid.
So we don't break it apart. We just write it exactly as is. So that'll be 2Na plus 2NO3 minus.
Yeah.
Okay, so to see how we combined the coefficients with each one of these. Now, do me a favor, underline the only thing right there that is not an aqueous in our ionic equation. Okay, that's the only thing. And what two things are forming the CaSO4? Underline the two things. Yep, so underline that and that. So those are the things that are going to be involved in writing our net ionic equation. Everything else is our spectators. So on the line right below, can you write Ca2 plus? Now this time we are going to write AQ. And those are typically subscripts, so just make sure that they're a little bit smallerish.
The bell rings in 1 minute.
Okay, so keep on writing this equation. Let's finish the equation out. I'll let you do this, and I'm going to grab the. Okay.
You just write AQ next to everything, right?
Yes.
What's the answer?
Is that the answer?
And that right there. Moved away, so I couldn't see it.
Would this be would Ca2 plus AQ plus SO4 2 minus AQ
CaSO4 liquid, yes, that would be the overall thing. All right, let everyone know that I will put the assignment for you guys to practice on online.
Okay. When's the test gonna be?
It's supposed to be on Friday.
Oh my god.
But I may try and postpone it.
Please do.
I still have you guys tomorrow and tomorrow's class, and then I'm gonna try and see if I can get one more class in.
Okay. Okay. Thank you.
The other teachers scheduled it for Friday, but I don't know if I'm ready for it on Friday for you guys.
Okay. Bye.
Bye.